So this is the October 2020 AS Paper 1 for Core for maths, and we've now we're on question 7, and excitingly we've got some integration, which is fun. So given that k is a constant, positive constant, and this equals that, show that that is true. Okay, where do you start? Well, you can only start where you're supposed to start. So we're going to integrate, find out what it is, make it equal to 4, and hopefully we can rearrange it and get something like that. No idea if it's going to work, so we've got to start somewhere. So first thing we've got to do, though, is get this ready for integration. So we're going to say that equals, between k and 1, we've got 5 over 2. We've got root x on the bottom. So that's root x is the x to the power of a half, and it was on the bottom, we make it minus. Plus 3 dx. Cool. So that looks pretty good to me, so that's where we're going. Right, so then we are actually going to integrate it. So I'm going to put my square brackets in, and I've still got my 5 over 2. I'm going to increase the power of x by 1, which will give me positive a half, and divide by that increased power. And I'm going to, so that would be kind of x to the naught, so I'm going to increase the power by 1, divide by the increased power, so that's x to 1 over 1, if you really want to go to that level. Between k and 1 equals 4. Okay, simplifying this and making, I might actually forget that for the minute. Simplifying this and making it look nice, I've got 5 over 2 divided by a half, so that will just leave me with 5, x to the half, plus 3x. Okay, and I'm still going between k and 1. So if I sub in my k, I've got 5k to the half plus 3k. Take away 5 plus 3. So 1 to the half and 1 thingy. And that's still equal 4. So I've got 5k to the half plus 3k minus 2. Okay, minus 8, I don't know where I got that 2 from, equals 4. Bring that over, and I've got, and if I write it as thirds, as they've got it, I've got 5 root k plus 3k minus 12 equals 0, which is exactly the same as that, just in a slightly different order. Okay, and then hence using algebra, find any values of k such that that is true. So that is still the same as this. So basically I've got to solve that. So I'm going to scrub this out and start with, so if I didn't know how to the first bit, then I would just use what was up here. So I've got something to solve. So I've got 3k plus 5 root k minus 12 equals 0. And what you need to do is to recognise that that is actually a hidden quadratic. So if we let x equal root k, then we've got 3x squared, because root k is at k, plus 5x minus 12 equals 0. And I think I'll probably use my calculator to solve this, because why not? 2, so I've got, 3 and 5 and minus 12. So they've told me the answer is 4 over 3. So I'm going to now just be sneaky and put in some brackets. So I've got 3x and x, because that's a prime number, there was nothing else it could be. And now I know that one part has got to be 4, so the other part has also got to be 3. And just thinking about that, I've got 9 and a 4, so that's got to be the positive, and that's negative. Just saves me thinking too fast. So then either 3x minus 4 equals 0, or x plus 3 equals 0, which means 3x equals 4, which means x equals 4 over 3, which is what I had in my calculator, which is why I knew I was going, and x equals minus 3. Okay, that isn't the end, because we don't want to know what x is, we want to know what k is. So we then go, okay, 4 over 3 equals root k, so k must equal 16 over 9. Or minus 3 equals root k, and at this point you're going, but it can't, because you can't have a negative, so that one doesn't work, it's impossible. Sneaky, huh?